All right, in this problem, we want to graph two different functions. We want to graph first y equals 3 to the x. So we'll go ahead and do that. We're just going to set up a table of values, and we did this in a previous lesson. Okay, -2, -1, 0, 1, and 2. And we plug this in. 3 to the -2 is 1/9. 3 to the -1 is 1/3. And go ahead and finish out that table. All right, so these are the points that we get. I can't quite fit them all in there, but you get the idea. And that's our exponential growth function. So now we also want to graph this logarithmic function. Now let me switch colors here. So I'm going to rewrite this in logarithmic form. So instead of log base 3 of x equals y, like that, I'm going to write it as 3 to the y equals x. And I'm still going to set up a table of values. Now, normally we plug in things for x's, but in this particular one, since it's 3 to the y, it's going to be easier to plug in y values. So I'm going to plug in -2, -1, 0, 1, 2 as my y values. So when I do that, 3 to the -2 is 1/9, and 1/3, 1, 3, and 9. Now, you may notice that these two things look a lot alike. Actually, just the x's and y's are switched. And also the tables look a lot alike, just the x's and y's are switched. That's because these are inverse functions, okay? Inverse functions are when we switch the x and y value. And now when I plot these points, the ones I've got in the green table over there, it ends up looking something like this. And remember, inverse functions are going to reflect across the line y equals x, which these definitely do. So any logarithmic graph you have is going to have this same shape to it. And we'll see that in the next one here. Let me scroll down and we'll graph this one. Okay, so just like we did before, I'm going to graph this. Switch colors again here. Maybe. So we are supposed to be graphing log base 9 of x equals y. And I'm going to write that as 9 to the y equals x. And then I'll create my table of values. Again, normally we plug in x's, but in this problem, it's going to be easier to plug in y's. And when we do that, 9 to the -2 is 1/81. 9 to the -1 is 1/9. And that finishes out the table. So I'll graph this. This doesn't really fit on here. It's over there somewhere. So again, same shape, just a little flatter than our last one. So these are the properties of a logarithmic graph, okay? This is a new parent function that you should know. Okay, when I ask you what does the graph of a logarithmic function look like, this is what you should have. Okay, it is always going to look like this thing. Okay, the domain is x is greater than 0, because remember, we can't take the log of negative numbers. The range is all real numbers. The x-intercept, all of our logarithmic graphs are going to go through the same point. It is 1, 0. They all have the same vertical asymptote, x equals 0. They are increasing and continuous, and the inverse, if you write it in exponential form and do the inverse, it's y equals a to the x. Okay, so that's our new parent function, and we can do transformations on this just like we would for any other parent function. So that's what we're going to see in this next one. So the first thing I'm going to do is graph this. This is the one that we just graphed earlier on the page. So it goes through 1, 0 and 3, 1, and it looks like this. So that's our parent function. Now, the next thing I want to do is this transformation to it, okay? That -1 is going to reflect it across the x-axis. Okay, so it's still going to go through that point, but it's going to get reflected over here. Looks like that. Still has the same asymptote, just reflected. And now for this one, this +3, that's going to move it to the left 3. So instead of going through this point here, we're going to move it to the left 3, 1, 2, 3. So this is that new point. Ignore that other purple one I just drew. This point here gets moved left, 1, 2, 3, right here. And the asymptote gets moved. So the asymptote was at 0. Our new asymptote is left. So this is what that function looks like. So our parent function and transformations still apply to all of these as well.